Okay, today we're going to cover some IGEMS 2D basics. In other words, I've drawn my part or imported my geometry. How do I program it and export a CNC file which I can run on my machine? We'll briefly go through initial setup, including defining your cutting head parameters, material type, and thickness, how to create a part out of a 2D geometry that you've drawn or imported, how to apply contours or toolpaths to that created geometry, a few edit tools if you want to make some tweaks, how to define your origin or start point and cut order within a program, and then ultimately how to post, process, and export your CNC file. We'll toss in a few tips and tricks along the way. So with that said, taking a look at my IGEMS CAD environment here, I drew this part using our CAD tools here. You could just as easily import a DXF or DWG or any other standard CAD format here. Once our geometry is defined, we're going to move over to our CAM tab. And we're just going to our workflow is going to work from left to right across this toolbar, from defining our initial conditions, creating our part, applying our toolpath, editing those if we need to, setting our start position or order, and then processing our CNC file. And you'll notice as I hover across some of these icons, I'll get little pop-up boxes that include numbers or other information. These are hotkeys on your keyboard if you prefer to work that way rather than clicking on these icons. So if I go to select my setup or my hotkey 0, today I'm going to be running an IGEMS CNC controller. My cutting head parameters include a 14 thousandths of an inch diameter orifice paired with a 40 thousandths of an inch diameter nozzle. My material type is aluminum, and my thickness is going to be 1/4 of an inch. We'll click OK. We'll skip over the sheet commands. These are useful if you're doing nesting, which we'll cover in a later video, and jump right to creating a part. When I click this or hit hotkey number 1, you'll notice down in the bottom left-hand corner, it will tell me which command is now active and what the system is waiting on for me to do next. So in this case, it wants us to select our objects. I'm going to grab all the geometry in my viewport here and hit enter. And in this dialog box, I have the opportunity to name this part, enter in a quantity, which today we'll just do 1, and then predefine the cut quality on a few different geometries. Now, if you don't get this right out of the gate, don't worry, we can always change it later. But today I'm going to select a medium cut quality for my external contours, and then an extra fine cut quality for my interior holes or contours, and click OK. So what you should see now is your CAD geometry gets colored in into a solid part. If it does not get colored in, or it's not what you expect your part to look like, you probably have some error with your CAD, be it an open line segment or a dirty import that you'll need to clean up and fix before you can progress to this next step. So provided everything looks good and what looks like what you're expecting, we're going to apply our contours, or hotkey number 2. And in here, I have a lot of control over defining the different types of contours or toolpaths that I'm going to apply to this part. So we can independently define external contours, internal contours, corner profiles, an alternative contour for special cases. And we can activate or deactivate any of these by clicking these checkboxes. Further, if you hit this little pencil icon, which stands for edit, you can burrow a little deeper into each one of these definitions and define the type of lead-in for each of them, the type of pierce, changing parameters like overcut, lead-in and lead-out length, approach angle or radius, and just get very, very granular in defining specific contours for specific material types and specific applications. So we're going to just accept the defaults today, and I'm going to do a multi-select. And again, it's asking me to select my parts. I'm going to grab everything in my viewport and hit enter. And you will see that it automatically applies a lead-in, an internal contour, and a rapid to all of the different geometry in my viewport here. Provided I'm happy with it, I'll hit enter again to go back to my dialog box. If I didn't like exactly where this lead-in or lead-out went, I can come and select my single tool and then edit the location of each of those approaches independently if I want. But I think this looks pretty good. We're just going to go ahead and kind of keep the defaults, and I'll hit enter to get back to my dialog and then close that out. Furthermore, if I wanted to edit or tweak some more, I could come over to my modify tools and click edit, And here it's going to show me my cut order, 1 through 10 on how the machine is going to progress across this part. If I click on any one of these numbers, I have the opportunity to come in and again tweak independent parameters on that specific toolpath or rearrange my cut order if I want to bump one of these up or down. But we're just going to leave all these as default for today. The last thing I'm going to do is way over here in my process tab. I'm going to select my cut order and define my origin. So if I select my order command, again, it's asking me to pick my part. We'll hit enter. And we're going to default to the lower left-hand corner here for our start position. So we had our start position and rapid to our first pierce. If I want to, I can move this 0 point around or manually click it to be somewhere else here in my viewport. We'll just kind of leave it down here in the bottom by default. The very last thing I'm going to do is process this part. So if I hit process and hit my process key here and then click OK, it is going to go through and we can say test part, enter, and it is going to generate the G-code file that is going to run here. So some of these other tools are a little useful as well. So if I click this little calculator, provided I've entered in the appropriate data, I can get a quick cost estimate to run this part. And there's a bunch of parameters here that'll help you quote jobs quickly, if you're bidding jobs. This is a report that will generate from the CNC file. So these reports are highly customizable. You can use this as a job traveler that goes along in your shop to each of your different workstations that an operator can use to pull jobs. This can exist either digitally or as a physical printout. I can do a 2D simulation of this part. So if I click this, hit OK, zoom out a little bit, and place my machine here, I'll get a quick 2D simulation of my catcher tank and the crossbeam on my machine going through and cutting this part. I can actually do a 3D simulation, which is useful if you're doing taper angle compensation parts or cutting 3D geometries. And again, we can run through and do a full 3D sim, doing tilt checks to verify that our cutting head setup is valid, or collisions if we have clamps or other tools, or work holding fixtures modeled within our environment here. Whoops, let's go ahead and pause that and exit. And then the last gear here are settings for setting up cutting parameters and whatnot, which we'll go through in a different video talking about post-processors. So provided everything is good, you've just created a CNC file that is now saved to a network directory somewhere or locally on your controller that you can then take and then run and then cut apart on your machine. So that's a quick crash course. There's obviously a lot more that we can go over, but those are the basics that you need to know from start to finish. Stick with us as we kind of go through some more advanced applications here. Any questions, head to our website at flexmachinetools.com. Reach out to us on the web via email or phone number, and we'd be happy to help you out. Thanks.